Hey guys, welcome back to another episode of Math Unlocked with Mrs. Rhodes-Grierson. So today we're looking at one of the, can be a very basic and yet sometimes tricky topic of patterns and sequences, right? So this is something that you would have been doing from as little as basic school, when you would have looked at something, figured out what pattern you're seeing, and then you would be able to predict what is the next term, or what would have been the next figure, or what would have been the next number. So for now, we're going to call it what's the next term. So that is referring to what comes next in the particular sequence that you're seeing here. Now, here I have my first column saying term number. So we're looking at starting at 1. So this is my very first number that I'm putting down, and I'm going to be counting up. So we're counting first one, second one, third one, fourth one. This here n is representing what another that could come in the sequence. It doesn't mean it's term number 5. It means it could represent any number of term that is existing in this particular sequence that we're going to be looking at. So there is one pattern that looks at whites, and let's say it could be a flag, and the flag has white, black, and 2 colors on patterns in it. So we're looking specifically at each one individually to see what is happening with that particular pattern. So I'm checking out, I'm observing to see what am I observing here. We're looking at patterns that have a specific thing that keeps reoccurring over and over. So when you look at this, you notice that we started out with 3, we went to 5, and now we're at 7. What exactly is happening here with this pattern or with this sequence? I start out with 3, I reach to 5, and then I come to 7, and the question would be asked, what comes next? Now, if you are a good observer, you would have seen, and I'm pausing so you can see it, I'm hoping that you would have seen that we're adding the number 2 to get the next term that is existing in this sequence. So I added 2 to 3 and I got 5. If I add 2, the same 2 to 5, I'm now at 7. So now that I've noticed that that is what is happening, if I want to know what's the next number that comes after 7, I would add 2 to 7 and it would give me 9. So I'm able to fill in that spot. Now I go over here and I notice that I start at 4, I end up at 7, and now I'm at 10. I'm checking, I'm observing. I notice that 4 plus 3 is 7. 4 plus 3 gives me 7. 7 plus 3 gives me 10. So if they ask what's the next number that would come in the sequence, I'd add 3 because I noticed the pattern is an addition of 3. And that would be my next term, would have been 13. I'm going over to the last column here. And I'm looking to see, is there something similar happening along that side? I started out at 1, I went to 5, and then I went to 9. Well, 1 plus 4 is 5. 5 plus 4 is 9. So I noticed that in this one, I'm adding 4. So I added 4. I added 4. So if I wanted to know what's the next one that comes, I'd add 4. And now I'm at 30. So these type of patterns are special patterns. They're easy to identify because we know that the same number that I add to each consecutive term, it will be the very number that is added to get the following term at all times. Starting from the first one, I added 2, I added 2, I added 2, and I will keep adding 2. Now notice something here, that by the time I got to term number 4, let's look at what's happening here. By the time I got to term number 4, I would have added 2 3 times. I'm going to repeat that. By the time I got to term number 4, which is 9, I would have added the number 2 3 times. So let me check out if something is similar with when I was at term number 3. At term number 3, I would have added 2 times. All right, let's check out term number 2. At term number 2, I would have only added 2 once. There is something that's happening right there. But if I was at term number 5, I'm assuming now that I would have had to add 2 to the 9 to get to term number 5. And by that, I would have added 4. I would have added 2 4 times. If you pick up the pattern, you would have seen that the term number that you're at, the number that I constantly add, that's that number that repeats itself. We call that the common, common because it's the same number that I keep adding. It's a common, we call it the common difference because between these two numbers, the difference that occurs between them is a difference of 2. So if I took 3 from 5, I would have gotten 2. If I took 5 from 7, I would have gotten 2. If I took 7 from 9, I would have gotten 2. So this number is considered to be the common difference. It's very common. It's the same number that we keep repeatedly adding to get the next term. But what we should realize is by the time we get to a particular term number, we would have added that number one number less than the term number itself. I'm going to repeat that. By the time I got to term number 4, I would have added 2 3 times. When I was at term number 3, I would have added 2 times. At term number 2, I would have added 2 1 time. At term number 1, no 2 was added. What does that mean for the nth term? When you do patterns and sequences, you always want to know what's the nth term, and that's an equation then or a formula that would be used to find any term that exists in the sequence. So based on what we just observed, we realize the 2 is constant. We kept adding that 2, and the number of 2's that we would have added is dependent on what number we are in the sequence. So if we're at term number 5, we would have added 2 4 times. An addition of 2, if I repeatedly add a number, I can condense that into multiplication. Because if I say 2 is being added 3 times, I could just say 3 times 2. If I say 2 is being added 2 times, I could say 2 times 2. If 2 was being added 4 times, I could say 4 times 2. So when we're writing our nth term, we're going to look at what is that number that I keep adding, right? What's that number? That number is going to become a constant thing. I'm adding it a couple of times. I'm going to say how many times. Whatever term number I'm at, I noticed that I would subtract 1 from that, from the addition of 2, because if I'm at term number 4, I would have added the 2 3 times. To accommodate that, we say 2 is multiplying what? 2 is multiplying n minus 1. Why did I say n minus 1? N represents the term number that I'm at. So for example, if I'm at term number 4, it means n is 4. So I would say n minus 1, 4 minus 1 would have been 3. So that means I would have added 3. I would have added 2 3 times. But instead of saying 2 plus 2 plus 2, I can say 2 times 3. So repeating that, if I'm at term number 4, I would have said 2 times 4 minus 1. That means it's actually 2 times 3. And the expression is to say that what if I'm not sure of what term I'm at? The n is a placeholder. The placeholder to represent what term you're at. But there's something very important that needs to be added to this statement. If I multiply 4 times, 2 times, let's look at this one. If I said 2, if I'm at term number 4, so let's say n is equal to 4. If I'm at term number 4, it would have been 4 minus 1. 4 minus 1 is 3, and 2 times 3 would give me 6. What do we need to consider? We need to consider the very first term was excluded from this statement. Why? Because the 2's that I kept adding would have not included the term number 1. It didn't include it because 2 times 3 would have given me 6. That 6 is representing that I would have added 2 3 times. However, that would exclude my very first term that was a part of the statement. So when we write the nth term, we must add back the original term, the very first one, which would have been the number 3 in this case. So this expression right here is representing that. For any term that I want in this sequence, anyone, if I want to get that term, I will need to first identify what's the number that I keep adding. That's the number. I kept adding 2. If I want any term within this sequence, the 2 that I'm adding repeatedly will be represented by multiplying by n minus 1. Where did you get the n minus 1? The n represents the term number you're at. So if I are at term number 4, it means that 2 was being added 3 times. Hence why we subtract 1 from the term number. So if it's at term number 4, it would have been 4 minus 1. Because the very first term was excluded from the statement, we need to add it back. So the 3 that was excluded from the addition of 2 needs to be added back such that we can get any term that we're looking for in the sequence. We're going to check this. Is this true? Let's start with term number 2. If I use this pattern, would it be able to give me the 5 that I'm looking for here? If I use this pattern, if n is 2, then 2 minus 1 is 1, and 1 times 2 is 2. 2 plus 3 is 5. Voila. It means, therefore, that this expression represents the nth term formula for any pattern that exists in this column. And what we're going to do is just to see, can we use it for all patterns that look like this? Yes, we can. Once it's a pattern that has a number that keeps repeatedly being added, same number, we can use this expression to represent it. Let's look at what's happening here. This one we were adding 2, but this one we were adding 3. So it means that outside of my bracket here, I'll put the number 3. What was 3? And remember that we're condensing this statement to say, instead of writing 3, 3, 3, 3, 3 each time, 3 is multiplying how much? N represents what term I'm at. I subtract 1 from it because the term that I'm at, if I'm at term number 4, it means I would have added 3 times. Hence, I would need to subtract 1 from that. But because we excluded the first term from the statement, we add it back. So that's number 4 because this was the one that was never affected. It was excluded because by I got to the 4th term, I would have added 3 times. But I need to consider that this was the starting point of the patterns and sequence here. So I must add the 4 to make the statement complete. Notice how this looks like this. The only difference is that now here we're putting what number we kept adding. What number? Here we must end with the very first number. In here we must ensure that it's n minus 1. So that means I can quickly do that. You could quickly do that. If you look at it, pause the video. Write down what would have been the expression for the nth term. Then you're going to just come back and check out my answer. So we're back. I kept adding 4, so I'm putting 4 right here. Open my bracket. I know I should put n minus 1. Plus, remember, I cannot leave off the very first term from the statement because it started the entire sequence. So I'll put my plus 1. These are what we call arithmetic sequences because they allow us to add up. Once number is repeatedly being added throughout the entire sequence. Once that is observed, then all of these can be expressed in a simple pattern like that.